Okay. So, okay, as you all might be knowing about the topic of this presentation today, that is correlation and regression. Or in this presentation of 2 hours, we will be able to cover these objectives, that is, and at the end of the presentation you will be able to understand all these things, what is correlation types, correlation coefficient कैसे calculate करते हैं, how to plot and interpret scatter diagram, और given data से किस तरह से interpret कर सकते हैं, और regression क्या है और उसके results को किस तरह से हम interpret कर सकते हैं. So for the time being, अगर किसी भी point पे आपको कोई confusion होता है, you can stop me there and ask or clear your confusion at that time only. So let us start with the correlation. तो कोरिलेशन एनालिसिस जो है वो एक बाईवेरिएट एनालिसिस है, और बाईवेरिएट एनालिसिस जब हम बोलते हैं तो इसका मतलब ये है कि कोई भी स्टैटिस्टिकल एनालिसिस जो कि रिलेटेड है टू द स्टडी ऑफ रिलेशनशिप बिटवीन टू वेरिएबल्स इज नोन एज बाईवेरिएट एनालिसिस. ठीक है. और वहीं अगर हम स्टडी करते हैं रिलेटेड टू कैरेक्टरिस्टिक ऑफ ओनली वन वेरिएबल, फॉर एग्जांपल अगर हाई, हाँ
मैंने इंग्लिश में बोलिए, मोस्ट ऑफ द पीपल आर फ्रॉम डिफरेंट स्टेट. ओके
okay. So what is the language barrier? Should I speak in English or Hindi?
मैडम इंग्लिश में.
अच्छा, इंग्लिश में. ओके, नो प्रॉब्लम. हाँ, तो I was telling about the correlation. So when we conduct the statistical analysis that is related to the study of relationship between two variables, then it is known as bivariate analysis, and correlation is a bivariate analysis. और जब when we conduct the study that is related to characteristic of only one variable, for example height या weight या age or such type of variables if we consider, then it is univariate analysis. And when we talk about the correlation, so correlation is a very common used word. We can say that most of the people commonly used it without knowing that they are using. For example, you might have seen when parents advise their children to work hard so that they may get good marks. So somehow they are correlating good marks with the hard work, है ना? And hard work we can consider time spent on studies. So there are two variables involved there, good marks and hard work. Hard work means we can say time spent on studies. So there are certain research situations also, means when a researcher conducts studies, so there are certain situations where two variables are involved, you know, and you are interested to know what type of relationship exists between those two variables. Okay. For example, if we talk about the health sciences, those who are in health researchers, those who are in health sciences, they study the relationship between, for example, BP and age, or consumption level of some nutrient and weight gain, total income and expenditure for etc. Such type of examples are there. So we can say that correlation refers to the relationship of two variables, relationship of two variables. Relationship, for example, जैसे कि as I have given examples, कि consumption level of some nutrient, weight gain in relation between those two variables, such type of examples are there. So if we go to the definition, then correlation is a statistical analysis which measures and analyzes the degree or extent to which the two variables fluctuate with reference to each other. Okay, it means कि if two quantities vary in such a way that movement in one movement means it may be either it may be upward movement or it may be downward movement in one quantity is accompanied by the movement in another quantity, then at that time we say that the quantities are correlated. So once you understand the concept of correlation, you will be able to answer the following types of questions. First I will tell you the basics of correlation, and then after that we will see ki how we conduct that in SPSS, or and how we interpret the results of correlation. So once you understand the concept, you will be able to answer the following type of questions. For example, whether study time in hours related with the marks scored in the examination. So you will see that in each question, there are two variables which are there, है ना? And we have to find the relation between them. Okay, so such type of questions are answered by the correlation. Is next one is it worth spending on advertisement for promotion of sales? Promotion of sales and spending on advertisement, how they are related, है ना? Whether price of commodity and demand related, how price of commodity and demand are related. Is there any relationship between rainfall and production of wheat? So such type of questions are answered by using the correlation concept. So let's see that how these questions are answered. Scatter diagram. Scatter diagram, a simplest method, this is one of the simplest method to study the relationship between two variables diagrammatically. है ना? Diagram के through means by drawing a scatter diagram, you can study the relationship between two variables, and this is one of the most simple method we can say, which gives a rough idea, which gives you a rough idea of relationship between two variables. Whenever a researcher or investigator collects two series of observations, है ना? Means observations about two variables, we can say, or two series of observation, then he wishes to see that whether there is a relationship between them. So to see the relationship, he will first of all construct a scatter diagram, है ना? How he will construct? In a scatter diagram, one variable is represented along the horizontal axis. This is the horizontal axis, and second variable is represented along the vertical axis. And for each pair of observation of two variable, we put a dot in the plane. Okay, horizontal axis is there, we represented by x. Vertical axis is there, we represented by y. And whatever the pair of observations are there in your in your data set, for example, you have collected the data x and y. Yeah, for example, I am taking that x is representing the height of father, y is representing the height of son. Okay, and for example, that you have collected 50 observations, so you might be having the 50 set of data, and for every pair we will put a dot in the scatter diagram. Okay, x and y, each axis will represent your this x and y, and for each set of observation we will put a dot in our scatter diagram. Obviously, if we are putting a dot for each observation, it means the total dots that will be in this plane will be the number of observations in your data set. Huh? Whatever the number of observations will be in your data set, that number of points will be in this your xy plane. So once you get the points, means whatever the observations are there, once you plot those on your xy plane, then just by seeing at the dots, or we can say just by seeing the direction of dots or scatter or concentration of these dots, you can tell the type of correlation between the two variables x and y. Okay, so what we do, on x-axis we take one variable, on y-axis we take another variable, and for each observation we put a dot, and after that the concentration of these dots tell us the relationship, the type of correlation between the two variables. Now there is a confusion that which variable to put on which axis. Okay, so always remember that vertical axis represent one set of measurement, and horizontal axis represents another set of measurements. Okay, so if one set of observation consists of experimental result, suppose whatever your output are, in that output, one set of observation is consisting of your experimental results, And another set of is consisting of time scale or observed classification of something of that kind. So usually what we do, we put experimental results on the vertical axis, and these represent what is called the dependent variable. Okay. And the another on the another axis, then that is called the independent variable, such as time or height or some other observed classification. But sometimes what happens that in whosoever the beginner is, he is confused between the dependent and independent variable, or there may be some possibility that means there may be possibility that sometimes each variable that you are taking x and y, they are dependent on any third variable, uh, means it is not clear ki which variable is dependent on what. Okay. So in that case, for example, if we consider ki if we are considering the height of children and age data, okay, so it is reasonable and it is clear that height of children will depend on the age rather than converse, है ना? We can't say that age will depend on the height of children. So it is clear from the given x and y that which variable is dependent on which, and which to take as the dependent variable and which one to take as the independent variable. Okay. But consider the another example where suppose x is your yield of rice, and y is your yield of wheat. Okay, yield of wheat, and we want to see the correlation between them, and we are plotting them. Okay. So now here we can't say that yield of rice depends on wheat or yield of wheat depends on rice. So which variable to take on x-axis and which variable to take on y-axis. Okay. So in such cases, it does not matter which scale is put on which axis of the scatter diagram. What you do is, if your intention is to make inference about one variable from the other, then the observation from which the inferences are to be made are put on the baseline. Okay. From means the variable from which you want to means variable which you want to use for drawing the inference is always put on the baseline, and variable about which the inference is to be made is put on the this vertical axis, that is y-axis. That will be your dependent variable, and the another one will be your independent variable. So remember, the variable which we want to predict, that will be your dependent variable, and variable which we want to use to predict the dependent variable, that will be your independent variable, and you will put it on x-axis. So I think now the confusion is clear, which variable to put on which axis. Okay. So now when we get this concentration of points, or when we get these points on our xy plane, then how to interpret these points? Now the problem is, once we get the scatter plot, once we constructed the scatter plot, the next problem that comes is how to interpret these points. Okay, how to interpret this scatter diagram. Okay, coming on to the next, that is how to interpret scatter plot. So there are different types, means we will study the each possibility ki which type of points will represent which type of correlation, and how we will interpret that. So first one is your positive correlation. Positive correlation means there is direct correlation. So we will say that your two variables are positively correlated if in your data set of x and y, larger values of x are associated with the larger values of y, and smaller values of x are associated with the smaller values of y. It means that if both the variables are varying in the same direction, then the correlation is said to be positive. If both the variables are varying in the same direction, it means things are moving in the same direction, then the correlation is said to be positive or direct correlation. This is the theoretical part. Next is how will you interpret it from the scatter plot. Scatter plots, how to interpret. So if all your plotted points form a band and they show the rising trend from the lower left hand corner to the upper right hand corner, the two variables are positively correlated. Okay, so if your points form such type of band, means we consider a imaginary straight line. Always remember that correlation tells the relationship between the two variables, but that is the linear relationship. Okay, correlation tells you the linear relationship between two variables. So let us imagine a straight line, and if your points are like this, means if they form a band and they show rising trend from this from left lower hand corner to the upper right hand corner like this, then we will say that the two variables x and y are positively correlated. It is clear now. If both the variables are varying in the same direction, then only such type of graph will be formed. Okay, then only, means if smaller values are associated with the smaller values of y, if larger values of x are associated with the larger values of y, then only such type of scatter plot or graph will be formed. Now, if you are getting such type of scatter plot in after plotting on xy axis, then we say that variable x and y are positively correlated. So I have given one example also, income and saving. As the income will increase, saving will also increase. Income is directly correlated with the saving. If we consider income as x variable and saving as the y variable, then as the income increases, saving also increases. So this is your positive correlation. Next one is negative correlation or inverse correlation. Just opposite to that, the previous one that we have seen. Always remember कि on your scatter diagram, the closer the points lie to a straight line, the closer the points lie to a straight line, the stronger will be the relationship between the two variables. Okay, so negative correlation is opposite to that of the previous one, that is a positive correlation. It is also called the inverse correlation. In this, things move in opposite direction. It means we say that two variables are negatively correlated if smaller values of x are associated with the larger values of y, and larger values of x are associated with the smaller values of y. Okay, it means it is clear that if such happens, then variables will vary in the opposite direction. Then they are said to be negatively correlated. If one variable increases, the other variable decreases, or and vice versa. And when we talk about the scatter plot, so if all the plotted points, means if there is inverse correlation, means that if one variable increase, then it means some relationship between x and y will be of something this kind now. So if your points, all the plotted points in the plane form a band and they show the falling trend from upper left hand corner to the lower right hand corner, then then the two variables are negatively correlated. It means if your points are like this and they form a band from upper left hand corner to the lower right hand corner, if your points are like this. Okay, and as I told you, closer the points to the straight line, stronger the relationship. Okay. For example, price and demand. Price and demand are negatively correlated variable. As the price will increase, demand for that particular commodity will decrease. As the price of any commodity or anything increases, its demand decreases. So price and demand are negatively correlated variables. Okay, let's see the most important where people do mistake in interpretation is uncorrelated. So two variables are said to be uncorrelated if they do not associate linearly. Okay, uncorrelation doesn't means that there is independence of two variables. So do not interpret it as if two variables are uncorrelated, then do not interpret it as two variables are independent. Instead, it is being interpreted as if two variables are uncorrelated, it means that there is no linear relationship between. It means no linear pattern exists between two variables x and y. There is no linear pattern existing between x and y, but there may be non-linear relationship between x and y, because correlation tells the correlation tells the linear relationship between the two variables, and if they are and uncorrelated, it means that there is no linear relationship, but there may be non-linear relationship existing between the two variables. So okay, when you plot, when on xy axis, when you plot x and y, both the variables, so if your points or if your dots are scattered over the xy plane, it means ki if they are spread over in a plane, है ना, no any such type of band is formed, है ना, they, if they are scattered or spread over in xy plane, then two variables are said to be uncorrelated. कुछ इस तरह का, if something like this trend is in something like this type of scatter is there, a scatter of points is there, or for example means linear means non-linear something relationship is showing like that, if your points are like this, no, like this means they are not along straight line, they're forming any type of curve or cone, something like that, means linear relationship is not there, or they are scattered in your xy plane, then we say that the x point variable x and y are uncorrelated. Okay, so let's see the perfect positive correlation. We have seen the positive correlation. Positive correlation means that if one variable increases, then other variable also increases. Means smaller values of x have the are associated with the smaller values of y, and larger values of x are associated with the larger values of y. So perfect. We say that two variables are perfectly positively correlated if two variables increase or decrease proportionately, then they are said to have perfect positive correlation. Okay. Proportionately means if all the plotted points of x and y of your scatter plot, they lie on a straight line. And since the positive, we are talking about the positive correlation, it means the points will be from lower left hand corner to the upper right hand corner. It means increasing trend will be there. So if your all plotted points lie on a straight line from lower left hand corner to upper right hand corner, then two variables are said to have perfect positive correlation. Okay, if something of that kind exists, then we say that there is perfect positive correlation between both the variables. Same is the with the another, that is perfect negative correlation. If x increases and y decreases proportionately, then they are said to have perfect negative correlation. It means if your points align something like this on a straight line, showing a straight line x and y, if your points are something like this, then we say that there is perfect negative correlation between both the variables. It means of all the plotted points lie on a straight line from upper left hand corner to the lower right hand corner, then the two variables have perfect negative correlation. Here is the small chart that I have given. You will be able to understand it in a more clear way. For example, first one is the perfect positive correlation, as I have told you. So there is, you can say, if the more close the points lie to a straight line, the more is the correlation. I have told you. So this is showing the strong correlation between x and y, and point lie on a straight line with y increases at x increases. This is perfect positive correlation. High positive correlation, the more the closer points to the straight line. It means the point lie close to a straight line with y increases, x increases. Whenever we talk about positive correlation, then the y increases as x increases. Low positive correlation, points will be more scattered around the straight line, है ना, but जो pattern है that will be around a straight line only from lower left hand corner to the upper right hand corner. No correlation, points are scattered around. low negative correlation, this falling trend is being shown, and where where your you can see that a trend is shown where y decreases at x increases, है ना? But points do not lie close to a straight line, they are scattered, little bit scattered. Here points are uh, points lie close to a straight line, and here points lie completely on a straight line. So these are the different types, and this is how you can interpret your scatter plot once you get the results. So this is the first step in investigating the in investigating the relationship between the two variables. And as I have told you, that it gives you a rough idea at a glance whether there is positive correlation, negative correlation, or the two variables are uncorrelated. So if we talk about SPSS, so let's see how to draw a scatter diagram in SPSS. Then we will move to the next part, that will be correlation. So this is our SPSS window, and let us take one example to show that how scatter plot is being drawn. So we are importing data from Excel, and suppose that we are taking this example of okay, let's take SLR4. Okay. So to draw the scatter plot, these SLR4 data I have taken it from one site where this X was national unemployment rate for adult males, and this Y was national unemployment rate for adult females. Okay. So let us draw the scatter diagram. If you want to change these variable names, then you can go to the variable view and change the names here. And if you want to label these variables, then you can label them under this label. Okay. If you want to label X, then you can write the name here. If you want to label Y, then you can write the name here. So coming on to the data view, if you want to draw the scatter plot, go to the graphs, chart builder. Then in this gallery, go to this scatter or dot plot and drag this scatter. As we want to draw this simple scatter plot only, there are many options: group 3D, summary point, and scatter plot matrix, drop line, all these. But we want to draw this simple scatter diagram, so we will drag this to this we will drag here. Okay. And after that, let's put X on x-axis and Y on y-axis. Okay. And after that, click OK. It is very simple to draw a scatter diagram. Click OK, and you will get this output window. And you can see here that your points are showing a rising trend, and they are rising. And this, if we imagine, then the points are clustered around a straight line. Since the point are less, means it is I think 10 or 15 data set, so that is why. But then also you can see the trend of line easily. Means if we imagine some straight line here, then you can see that these points are scattered around a straight line, and they are showing a trend that is increasing. That is increasing, means both you can easily interpret that X and Y are positively correlated. And if you want to draw that straight line, then double click this window, this chart window, double click, and after that see the options that are given here. So here this option, click on this option, add fit line at total. When you will click on this option, it will draw a straight line on your chart like this. Okay, so now it will be easy for you to see that how these points are scattered around this straight line only. So you can say that there is x and y are linearly correlated, and there is a positive correlation between both the variables x and y. So there are other options also which you can do here in chart editor, and then if you want to use it for your analysis purpose, you can copy and paste, copy it from here and paste up to your wherever you want to conduct the analysis part there. So if you want to make the other changes also, from here you can change the colors, and there are many options. If you want to insert a title, go to here. If you want to insert annotation, and this is if you want to insert a text box, even you can change this x and y. If you want to change this title name, text style, text layout, chart size, so there are many options. You can explore all those options once you try with the data set, draw the scatter diagram, and after that on this chart editor you can try the many options that are available there. More you explore, more you get to know. Okay, so this is how we draw the scatter plot. There are other options also, means you can take other data also. There is this groundwater survey SLR9. So let's take one more example. We will import the data from Excel, and this is your SLR9. Okay, SLR9. तो दिस इज एक्स एंड वाई ग्राउंड वाटर सर्वे था इसमें इन दिस एक्स वाज आई थिंक द पीएच लेवल, एक्स वाज शोइंग द पीएच लेवल, एंड वाई वाज द बाइकार्बोनेट लेवल इन द वाटर. ठीक है, तो here x and y you can interchange it, because we want to, if we are conducting the study, such type of water level study, then obviously we want to predict the pH level by using the bicarbonate level. If such type of study we are conducting, then your y will be your this pH level, and this will be your x. So you can easily change in this, go to this variable view and change the names and change the label here. You can put it as pH level. Suppose this one was our pH level, and this one was bicarbonate level in the water. Bicarbonate level. Okay. So we will data view. Now when you will draw this chart or this scatter diagram, then you will see that these variable name that we have changed, that will be shown there only. This is we are putting on x-axis. You can change the axis also, that doesn't matter. If you are changing the axis, then also scatter plot will show the same relationship between x and y. So this is your, as I told you na, yeah, I have changed the name there in the label section. So the now names are here, pH level and bicarbonate level. In the previous one, I haven't changed, so they are showing x and y only. Whatever was written in the variable section. So this is the graph between pH level and bicarbonate level. So you can easily see the this band of points. They are showing some this decreasing type of trend, right? You can see that points are clustered in this way. If we imagine some line this side like this, then we can say that points are scattered around the line. So just by looking at the scatter plot, we can say there is negative correlation between both the variables. And if you want to draw that line, then you can go to this option, add fit line at total, and you can see, as I told you, the points are scattered around this straight line. So we can say that x and y, pH level and bicarbonate level are negatively correlated. means if we put this bicarbonate level this side also, then the same result will be there. The negatively correlated with both the variables. It means if the bicarbonate level in the water increases, then the pH level decreases, something like that. If one thing increases, then other thing decreases. We can interpret it like that way. So this is how we draw the scatter plot. Moving on to the next, and we will do other examples of calculating the correlation coefficient. Okay, coming on to the next, that is statistical tool selection. Uh, Abhi tak means what we have covered till now is the scatter plot. So through scatter plot, we got some idea about the direction of correlation, but we cannot establish the exact strength of correlation between the variables. And it is true also, and we cannot establish the exact strength just because there is no mathematical formula. There is just a diagram, and through that, just by looking at that diagram, we are interpreting the result. So we have seen that the purpose of correlation analysis is to find the existence of linear relationship between the variables. And scatter plot gives us a rough idea. So correlation coefficient is calculated to quantify the strength of relationship. To quantify the strength of relationship between the two variables, correlation coefficient is being calculated. But the method of calculating the correlation coefficient depends on the type of measurement scale that we are using. Now, it means your variables x and y, they are being measured on which scale. It depends on that. Means which method of calculating correlation coefficient we are using. That completely depends on the scale on which our variables are being measured. Okay, if your variables are being measured on nominal scale, use Yule's coefficient of association. Ordinal scale, Spearman rank correlation coefficient. Continuous or ratio scale, then use Carl Pearson correlation coefficient. So you all might be knowing nominal scale we use when to name or label a series of values. Ordinal scale we use where only order matters. You know? For example, that how did you feel yesterday after the trip? You know? So you will write it as very unhappy, unhappy, okay, happy, very happy, like that. You know? There will be such 4 to 5 options. Then you can say that means very happy is better than okay. Okay, but you don't know how much it is better. No, we don't know the difference, but we know that yes, it is better. Means there is only order that is matters in this ordinal scale. So if such type of data is there, then we will use Spearman's rank correlation coefficient. And Carl Pearson correlation coefficient अगर ratio scale है, it means the variables that can be meaningfully added, subtracted, multiplied or divided. Such type of things are there. So statistical tool selection means which correlation coefficient method to use. Okay, coming on to the Carl Pearson coefficient of correlation. So if your x and y are linearly related, है ना, and x and xy has bivariate normal distribution, the coefficient of correlation between x and y is defined as we are quantifying the correlation. We are quantifying the relationship by calculating the coefficient of correlation, that is denoted by rxy, covariance divided by variance of x y under a square root में, है ना. So this is the formula that we use for calculating this correlation coefficient, which is also called the product movement correlation coefficient. Or this was defined by Carl Pearson, and the value of rxy lies between -1 and 1. Okay. Now, how to interpret these results? Means if you once calculate, suppose x and y is given in your data set, and from the data set you have calculated the value of r. Okay, suppose some value comes, suppose some r comes to be 0.25 or something comes. Okay, then how will you interpret this result? How will you interpret the result of your r equals to some value? So if the value of r comes to be positive, then it indicates a positive correlation. As I told you, scatter diagram from increasing trend, it shows the increasing trend. So if positive value is there, then positive correlation. Negative value is there, then negative correlation. If value of R comes to be negative value, and that too in this range only, है ना? Positive value means that it will be from between 0 to 1. Negative value means it will be from -1 to it will be less than 0. Okay, something like that. It will be less than 0, -1 to less than 0. Okay, greater than 0 to 1, then positive correlation. Now, if R is equal to +1, then perfect positive correlation. And proportionately increase when there is proportionately increase when one variable increases. -1, perfect negative correlation. It means when there is proportionately decrease when one variable increases. If R is equal to 0, then we say they are uncorrelated. It means there is no linear relationship between the two variables. Further, if we want to verbally describe, then a strength of correlation was described by Evans in 1996, and he suggested the absolute value of R. If something lies in this range, then we will use such type of adjectives for that. It means if your value is lying between 0.80 to 1, then we will say there is very strong, and positive or negative depends on positive value is there or negative value is there. If your value is between 0.80 to 1, and if it is positive, then you will say that very strong positive correlation between the two variables. And if the value is from point 0 to 0.19 in negative, then we will say very weak negative correlation is between the two variables. So such type of adjectives can be used that were given by Evans. He suggested the different adjectives for the absolute value of R. So this is how you will interpret the correlation coefficient R. But remember, before performing this means or calculating the coefficient of correlation, you need to see that whether the assumptions are being fulfilled or not. Assumptions of calculating the correlation coefficient are being fulfilled or not. Assumptions, what are the assumptions? First one is कि they should be linearly related. X and Y should be linearly related. For that, you will have to check the scatter plot. Draw the scatter plot and check that there is linear relationship or not. If it is there, then you can calculate coefficient of. Then check the second assumption that X and Y have bivariate normal distribution. To check the bivariate normal distribution, what you will do, check that both variable are normally distributed. Individually also you can check. Individually also you can check that whether both the variables. For that you can draw the histogram. For X and Y both, you can draw the histogram, or you can draw the box plot also shows. And then also if it is not clear from the box plot also, then you can go for the skewness, check the skewness of X and Y. And but you will have to verify that X and Y have bivariate normal distribution. So for you can individually check that X is normal, is X is following normal, Y is following normal. Okay. And third one is interval or ratio scale, means your values, your variables should be measured on interval or ratio scale. Then only you can use Carl Pearson coefficient of correlation. So if these three assumptions are not being met, then what happens? As I told you, Carl Pearson coefficient of correlation we can use when these three assumptions are being met. Means if they are bivariate normal distribution है, linearly correlated हैं, और इंटरवल या रेशियो स्केल पे मेजर किया गया है, then we can use this coefficient of correlation. But if these three assumptions are not met, also check for the outliers. Outliers is also important. And if your data does not meet the above assumption, then in that case, don't use Pearson coefficient of correlation. Go for the Spearman rank correlation. That is the another one. Okay. This another one, Spearman rank correlation coefficient. If the assumptions are not being met, if the assumptions of Carl Pearson correlation coefficient are not being met, then go for the Spearman rank correlation. And you can easily change the data in ordinal scale, change them to the ranks. जो है उनको rank, arrange them according to the ranks, and you can easily get the ordinal data. So this is, I have conducted one example where X variable shows the height of father, Y variable shows the height of son. these two data on these two variable is being conducted, and data is on ratio scale, so we use Carl Pearson method, and you can verify that it is following that. This is just I have shown this example to see that how the R is calculated by hand and how it is interpreted. Okay, so means by using this formula only, covariance xy divided by square root of variance x and variance y, we got this value of R equal to 0.603. So we can see that the 0.603 lies in this range. It means we can say they are variable, both the variables are strongly correlated, strongly positively correlated, since the value is positive. So we can interpret it in this way that height of father and height of son both are positively correlated. It means that on the average, if fathers are tall, then sons will probably be tall. And if the fathers are short, then probably son may be short. So in this way, you can interpret the result that you get, whatever the value of R you get. Okay. So next one is the Spearman rank correlation coefficient. I have told you when to use if data are in ordinal scale, if data is are in ordinal scale, or your given data is not following the assumptions of Carl Pearson's coefficient of correlation. Then in that case, go for the Spearman rank correlation coefficient. Spearman rank correlation coefficient में we use this formula, rho is equal to 1 minus 6 summation di square divided by n to n square minus 1, where your di is the difference between the ranks of both the data set. First of all, you will compute the R1, that will be the rank of first data set, the suppose X. Then you will compute R2, that will be the rank of second data set. Then compute di, that will be the difference between the rank of both the data set. Then compute di square, that will be the square of difference. And then this di square, sum this di square, and it is used here in this formula and is the number of observations. Okay. And how will you interpret the result of Spearman rank correlation coefficient? If your value of rho, है ना, इसको we don't denote it by rho. In different books, notations is also different. Somewhere correlation coefficient, Carl Pearson correlation coefficient is denoted by rho. Somewhere Spearman rank correlation coefficient is denoted by rho. Okay, so if the now how will we will interpret this result? If the value of rho comes to be positive, है ना, then we say that there is agreement. And if the value comes to be negative, then we say that there is disagreement. है ना? This is such because actually Spearman correlation coefficient, we use it for the subjective data. For example, competition scores. So what we do, as I've told you, we rank the data from low to high or high to low, like that, and then we assign the ranks to that data. And if the ranks are given, then it is far so better. If the ranks are not given, then we assign the ranks from high to low or low to high. And after assigning the rank, we put this formula, we apply this formula, or it tells you Spearman rank correlation coefficient tells you the strength of monotonic relationship between pair data, you know. And its interpretation is same as that of Pearson one. Keep positively correlated, high, moderate, weak, very weak. So this is how you can do it. Positive range, then you can say 0.80 to 1, very strong agreement, moderate, weak agreement, very weak agreement. So if such type of range, your value of rho lies in any of the range, then you can interpret it accordingly. Let's see this example. Spearman rank correlation coefficient calculate करने के लिए I have written this example. In a flower exhibition, 2 referees rank the 10 types of flowers as follows. Okay. And we will use rank correlation coefficient to find out the degree of agreement between the referees. Okay. So this is your rank 1, the rank 2. Ranks by the referee 1, ranks by the referee 2. Di is the difference between both the ranks. Di square is the square of the difference between both the ranks. Okay. Now here we have computed the value of di square, and finally we got the result 0.636. It lies in this range, strong, and since positive, so we will say strong agreement. Okay. So degree of agreement between the referee A and B is 0.636, and they have strong agreement in evaluating the competitors. So we said that they have strong degree of strong agreement in evaluating the competitors. So in this way, the value can be computed and interpreted. This is about Spearman rank correlation coefficient. Yule's coefficient of association is used to know the existence of a relationship between two attributes A and B. Attribute means quality or any feature, and we consider the attributes. For example, drinking line. These are the examples, and this yes or no represent the presence or absence of that attribute. Okay. So if we draw this contingency table where A attribute presence absence shows, B attribute presence absence shows, and AB in bracket, alpha B in bracket showing that what is the number? It is showing number with attribute A, and with the presence means that number, how many are there in which attribute A and attribute B is present. Okay. A beta is showing that how many numbers are there in which attribute A is present but attribute B is not present. Okay. Alpha B means attribute A is not present but B is present. So in this way, after drawing this contingency table, Q is being calculated, by using this formula, and by after calculating Q, it ranges same as correlation coefficient from -1 to 1. And if value range from -1 to 0, it indicates the inverse relationship, and if it ranges from 0 to 1, it indicates the direct relationship, that is direct association between the attributes. This is one example that we have taken. There are 1800 candidates. This means say competitive exam mein 625 were successful, 300 had attended coaching class, 180 came out successful. So how to test for the association of attribute attending the coaching class and success in examination? We calculated Yule's coefficient of correlation. So this is, we have drawn the same table. We have used the formula that I told you, and value comes out to be 0.561. 0.561 means there is, we can say that there is positive association. How to interpret this result? This shows that there is positive association between A was success in examination, B was attended the coaching class. So there is positive association between success in examination and attending coaching class. So we can say that coaching class is important for success in examination. We can also interpret it like that way. So it is showing the positive association between both. So this is how you can interpret Yule's coefficient of association. Okay. Coming on to the most important thing, that is the testing the significance of correlation coefficient. Before that, let me tell you the limitations of correlation. Right? There are certain limitations also, although correlation is a powerful tool which tells you the relationship, but there are certain limitations to it also. There are certain limitations to the correlation. Outliers, the one problem is with the outliers, means extreme observations. If there are extreme observations, then they may influence your correlation coefficient. Then you will have to detect, in that case you will have to detect the outliers and you will have to remove them. We should be careful about the conclusion when we draw from the value of R. You will have to look for the outliers. If there is outlier, then it will influence your value of R. So outliers may be dropped before the calculation if we want to draw the meaningful conclusion from the value of R. Okay. So first limitation is your outlier. It must be taken care of. Second problem is, limitation is correlation does not imply the causal relationship. does not imply the causal relationship. Causal relationship means you cannot interpret from the result that one variable causes the change in the another variable. No. From the data you can't interpret such type of things. Means if there is a strong correlation between two variables, then that strong correlation does not imply any kind of causal relationship or causal link between the variable. For example, we cannot imply that suppose correlation is being computed between hemoglobin and PCV, some problem, okay, and there is very strong correlation between both, okay. So we cannot imply that hemoglobin level causes PCV, okay. We cannot say, means it does not, correlation does not show the causal relationship between the two variables. There may be some possibility of, and there may be any third variable which is causing this relationship. There may be some third variable that it may be possible that it is depending on that and PCV is depending on that. That is why both the variables are increasing. This may be the possibility. So whenever you are calculating the correlation coefficient, so remember that you cannot interpret the result in that way that change in one variable is the cause of change in the value of another variable. Because correlation only shows the variable, but it does not yani ki, that we will see in regression. Okay. So these are the two limitations you should taken care of when you are interpreting the data of correlation coefficient. Okay. So let's see the testing the significance of correlation coefficient. Significance, objective of significance test is to assess that whether there is really a correlation between random variables, or it is just by chance, or it is just by coincidence that the value of R comes out to be something highly positively correlated or something highly negatively correlated. So this testing or the significance of correlation coefficient is done for that reason only, to test that whether there is really a correlation and or this result is coming just by chance. And then only if if the result is significant, then only that result can be used to predict the another variable, जैसा कि हम regression में करते हैं, ठीक है. अगर significant result है तभी हम उसको predict करने के लिए we can use that for the prediction purpose, otherwise we cannot. Okay. So how to use t-test to determine significance. We use this null hypothesis, that is rho equal to 0. H1 is rho is not equal to 0. Two-tail test. Specify level of significance and then determine the degree of freedom. After that, calculate this your t statistic. Calculating the t statistic, then make the decision. So to interpret the result, if you reject H naught, then you can say that there is significant linear correlation. And if you fail to reject H naught, then it can be then you can conclude that there is statistically no significant linear correlation. And in SPSS, to test the significance of correlation coefficient, you will see that SPSS reports for the p-value. It gives the p-value. It does not give the t-test. Give it does not give this t-value or something. It gives in SPSS, it reports for the p-value for this test, significance test. And if this p-value comes out to be less than 0.05, then we say that we have some strong evidence to believe that both variables are linearly correlated. And in that case, we can say that there is some relationship between the variables, and means the result will be significant if your p-value comes out to be less than 0.05. In SPSS, I will show you just after this. In SPSS, your p-value will show something like this 000, and here it will be asterisk given, and below the table it will be written asterisk shows the significant result at this point or at this level of significance, something like that will be written. So this is how the significance of testing the significance of correlation coefficient is important, just to see that the correlation is just by chance, or is it really significant. Okay, so let's see this in SPSS. We will take the same example only, this example of this pH. X was your pH, showing your pH level, and Y was showing your bicarbonate level. Let us change this. Okay, I will change it to Y and this to X. I will change this to Y and the second one to X. Okay, so I have changed data view. This is Y. This Y was showing the pH level, as I have told you in the previous example, and X is showing the bicarbonate level. Okay, so we are interested in relationship between the two variables. So for that, in the variable view, we have changed the variable name Y to the this pH level and X to the bicarbonate level. And order of data here does not matter as long as both the pairs are together. Pair should not be differed, because each pair gives the data, gives the one set of observation. So pair should not be mismatched. Order can be changed. Means this first observation can be put on 12th, 13th, 14th, like this. This order can be changed, but this X and Y for a particular set cannot be changed. Now to calculate a correlation coefficient, go to analyze. We will go to analyze. In analyze, go to correlate. Correlate, go to bivariate and click on the bivariate. Okay. So there are different types to calculate, but we are calculating the Pearson. Pearson correlation coefficient. Now we have variables on the left hand side, and we have to move these variables to this window. Okay. So we will move both the variables Y and X on right. So since this is bivariate analysis, then we will need at least two. If we are having only one variable, then OK sign has gone. It is not showing the OK sign. Okay. So we will have to pass both the variables to calculate the to see the relationship between correlation coefficient to calculate the correlation coefficient. So we have moved both the variable to the variable section, and now we have different options also. Okay, so we will go to the test of significance. We are doing a two-tailed, row not equal to 0 considered. Now means this test of significance, why it is done, I have told you. So we expect to see similar results in the real world. Means we need to check that it does not occur by chance. Now we will click OK. Let's see in the options. Okay, we don't need all these things. So you can explore other options also if you want. Then click on OK. And after clicking on OK, we will get the result somewhere. This is the result window we are getting. Okay. This is showing the correlation table, type of matrix it is showing. Correlation coefficient of every combination. Since we have taken two variables, so it is showing the correlation coefficient between two variables only. pH level and pH level, obviously the correlation will be 1. pH level and bicarbonate level, correlation coefficient is minus 0.340. Bicarbonate level and pH level 0.3, means it shows all the possibilities, means all every combination of variable. So if we are computing the correlation coefficient between two variables, then it will show 2 rows and 2 columns. We have two variables between pH and pH and bicarbonate and pH, bicarbonate and bicarbonate, in this way. Okay. Now we will go to the next, that is, first one is Pearson correlation. So we have seen minus 0.340. You know? So minus 0.340 is negative correlated, you know? And not, we can't say highly negatively correlated, and negative correlation is there. And in the graph also we can see ki jo scatter the points and they were scattered around, you know? They were not closely uh, mm, they were not too close to the straight line, they were scattered about the straight line. So it is obvious that the correlation coefficient value will be minus something like 0.340. So as I told you, here is a star sign, you know, asterisk sign, and this asterisk sign shows that correlation is significant at 0.05 level. Okay. And the p-value is coming to be 0.049. We are at the boundary. So if this value will be greater than 0.05, then it will show something else here. It will not write that correlation is significant. So it is testing for the significance, because we clicked that, if you have remembered that, we clicked on that. So after that, n is showing the number of observations. Now significance level, we are interested in the correlation between bicarbonate level and pH level, and we can see the significance level is 0.049, and it may be 0.01 also. So anything less than 0.05 means that correlation is significant. So we will probably means we can say that this result is significant if this value is coming to be this. Now we can easily compare both the values, negatively correlated in this. You can also check for the assumptions of this. Assumptions, as we already seen, they are positively correlated, and the value was also on ratio scale. And third assumption was your for that they are normally distributed or not. So for that you can draw the histogram and see your results. Yeah. So this is how we will draw the correlation matrix, and even it can be drawn for means correlation matrix can be drawn for more than two variables also, 4, 5, 8, 10, as many variables as you want. So let us see one example with more than two variables also. So we will import data for multivariate data. MLR, multiple linear regression. Okay. So we are taking this example, MLR 9. So this there were 5 variables, x1, x2, x3, x4, x5. So label is not given, no problem, no issues. We will just see how to analyze for the correlation if there are more than 2 variables. So since here are 5 variables, so we are going to take all the 5 variables in one go to see the correlation between them. We have clicked on two-tailed test. So you can click here. There is showing show only lower triangle or show diagonal, because it shows all the possible pairs. Na? So you can click on show only lower triangle, or if you want to click on show diagonal, then it is okay. Otherwise you can put it off, because in diagonal it will show only the value 1. Na? Because x1 the correlation between x1 and x1 will be always 1. So it will show 1. Now we will click OK. Now see this correlation table. This correlation table, it is showing we were having 5 अच्छा, फर्स्ट वन इट इज नॉट शोइंग just because of x1 and x1, तो 1 होगा इसलिए. So it is showing 4 cross 4 table. Okay, so 4 cross 4 table, you can see here 0.834 correlation between x1 and x2, significant, less than 0.001. Number of observations 54, right? It means it has taken all the observations. X3 and x1 0.496, x3 and x2 516, significant. Okay, we will see where it is not significant. Here, you see there is no asterisk sign. You know, double asterisk is showing that correlation is significant at 0.01, and single asterisk is showing that correlation is significant on 0.05. Or where there is means the correlation is not significant, it is not showing any asterisk, because this significant value is greater than 0.05. That is why it is not means this the x4 and x1 are not significantly cool, and x5 and x1 also same for x5 and x1, x2 and x5. So in this way you can correlate for more than two variables also, and you can correlate it for you can calculate the correlation for two variables also. This is how you can do. So any problem up till now here, you can tell me. We will move to the next. We are running short of time, only 40 minutes are left. Okay, moving on to the next topic, that is regression analysis. रिग्रेशन एनालिसिस एक स्टैटिस्टिकल मेथड है ये डिटरमिन करने का कि मैथमेटिकल फंक्शन रिलेशनशिप, determining the mathematical function relationship connecting an independent variable and a dependent variable. So correlation coefficient को हम जब यूज कर रहे थे एज अ स्टैटिस्टिकल टूल, तो would ये correlation coefficient was describing the type, means positive, negative or uncorrelated, and intensity of linear relationships such as high or moderate between two variables. But it fails to give the mathematical functional relationship between the two variables. So regression analysis is a statistical method for obtaining the functional relationship between a dependent variable and a independent variable. Okay. Dependent variable is sometimes it is also called the response variable. Response variable. Independent variable is sometimes also called the regressor, or it is also called the predictor. Predictor इसलिए because it is used to predict the dependent variable. We use the independent variable to predict the dependent variable, and dependent variable is a variable which we predict. Okay? Means about which we want to draw the inference. That is your dependent variable. So more specifically, if we talk about the regression analysis, then it helps us to understand how the typical value of dependent variable changes when any one of the independent variable is varied, while the other independent variable are held fixed. Means it helps to determine the impact of changes in the value of independent variable upon the changes in the value of dependent variable. So it is since as I have told you that is it is used to see the changes when any one of the independent variable is varied. So we can say that it is used for the prediction purposes. There are different types of regression that are used based on kind of relationship between dependent variable and set of independent variable. There are two broad categories: linear regression, non-linear regression. Linear में simple linear regression, multiple linear regression. So if the relationship is linear, then there is the relationship between the two variables is if the relationship between the two variables is linear and there is one independent variable, then a regression is simple linear regression if there is only one independent variable. and the relationship between the both the variables is linear. And if the relationship between the both the variables is linear and there are more than one independent variable, then it is said to be multiple linear regression. Non-linear, it is clear from the name. If the relationship is not linear, then the regression is said to be non-linear regression. So we will talk about the simple linear regression and also the multiple linear regression. In short, I will tell you about the multiple linear regression also. So simple linear regression is actually a very widely known modeling technique where your dependent variable is continuous and independent variable is continuous, or it can be discrete also. And nature of relationship is linear. And the relationship between both the variable is shown using a best fitted straight line. You know? Actually, when we talk about the correlation, it just tells you the relationship between the two variables x and y. You know, through the scatter diagram or by plotting the value of r, like that way. It tells you the relationship between the two variables x and y. But regression tells you that if the value of x increases by 1 unit, then how the value of y is changed. Now, if the value of x is varied, then how those changes are being seen in the value of y. This is what we study through the simple linear regression. And this is being studied through a best fitted straight line. Okay. Through a best fitted straight line, we can, best fitted straight line is used for the prediction purpose, where the general form of simple linear regression equation is y equals to a plus bx plus c, where your y is dependent variable, x is your independent variable, a is the intercept, and b is the slope of the line. Okay, and e is the error. So we use this equation to estimate the value of this response variable, that is y, by using the predictor variable, that is x. By using this predictor variable, we estimate the value of y, that is your response variable. Okay. Now, how this line is fitted to this data? As I've told you, simple linear regression, we use the best fitted line, and this best fitted line, which is also called the regression line, this best fitted line is used to predict the value of y. Then how this best fitted line is, we can say that what is the method to fit this line. Okay, so there is method of least square, which is used to determine the line of best fit in such cases. Okay. It helps us to find the value of unknown a and b, because if we want to fit a line to the given values, as I have told you that this is the regression line which is being fitted to the values of x and y. So if we want to fit a regression line, that is y equals to a plus bx plus e, it means that we need to calculate the value of unknown values of a and b, because for the given set of values there can be many lines that can be drawn, you know. For the different values of a and b, we can draw different lines through these points, but which line will be the line of best fit? It means which line will approximate the values of x and y. It means that the line with the smallest distance between itself and each point of the observation. Okay. Line of best fit means the line which will be having the minimum distance between itself and the observations, which will be having this minimum distance. And there can be many lines that can be drawn. If this line is to be drawn, or if this line is to be fitted, or this model is to be fitted to the given data, then model fitting means we need to calculate the value of a and b, and for the different values of a and b, we can draw the different lines in the to this data. But our aim is to find for the line of best fit. To how to draw that, for that method of least square is used. And what the method of least square does is it minimizes the vertical distance between the observations and the regression line. This is your regression line, and this method minimizes this vertical distance, which is also called the error term, है ना? This vertical distance, or we can say this difference between the observations, these are your observations, okay? And if this line is being drawn, the value which will lie on this line will be your estimated values, and these values are your actual observations or actual values. So the difference between these, the difference or vertical distance between the observation and the regression line are called the error terms. They are denoted by EIs. So linear regression chooses the estimated values for intercept A cap and slope B cap such that this sum of squared vertical distances between the observations and the regression line is minimized. It is written here that method of least square, what it does, it helps to find the value of unknown A and B in such a way that sum of residuals is 0 and sum of squares of residuals is least. And this sum of squares of residuals is least. We have to do this to find the sum of squares of residuals. What we need to do is we need to find this distance, the minimum distance. Okay. Because in most cases data means it is not necessary that your data points lie on a straight line. You know, they are not highly correlated in all the cases. So it leads to possibility of depicting the relationship between two variables. So obviously there will be several lines. So selection of each may lead to situation where the line will be closer to some point and farther from the other point. So in that case, we cannot decide which line to choose. So I was telling you about the best fit line. So least square method is used to choose for the best fit line. So how this fitting is done? Least square method is applied to determine the, okay, this is method of least square is applied to determine the estimates of A and B in simple linear regression equation using the given data. If the data is given x1, y1, x2, y2 to xn, by minimizing this E value, which is summation over yi minus y cap whole square, where your this y cap is a plus bxi. It means that is the this expected or estimated value of your response variable. Okay, these yi are the observations, as I have told you. These yi are the, suppose we consider that these yi are the values and yi cap are the estimated value that lies on this straight line. Okay, and since we want the best line of best fit, so we need to reduce this distance. So for that we will differentiate this with respect to A and B, and then we will equate it to 0. Okay, it is obvious that if expected value yi is close to observed value yi, the residual will be small. Since the magnitude of residual is determined by value of A and B, estimates of these coefficients are obtained by minimizing the sum of squared residual. So we will differentiate this EAB with respect to A and B and we will equate them to 0, and we will get these two normal equations in this form. You know, we will get these two normal equations where from the data we will be knowing all these values. You know, summation xi, summation yi, summation xi will also be known, summation xi square will also be known, summation xi yi will also be known. So we will get all these values from the data set, that is x1 y1 to xn yn, and after putting all these values we will get the two equations, and those two equations we will be having two equations and two unknowns, and by solving those two normal equations we can get the value of A and we can get the value of B. This is what we were interested in. है ना? We were interested in computing the value of A and B because we were fitting the line of best fit, and to fit the line of best fit what we need is we need the value of A and B. है ना? So we will get the A value of A and B from this, and we will plug in these values of A and B in this equation, that is y equals to A plus Bx. After plugging in the values, we will get this line as a line of best fit, and for the particular value of x, we can predict the value of y. This is what we do through the regression, कि x की पर्टिकुलर वैल्यू के लिए फिर हम y की जो वैल्यू है वो प्रेडिक्ट कर सकते हैं once we compute the A and B. So important thing is here, we will get this regression equation, and after that we can compute. So this is the procedure of fitting a simple linear regression equation. We minimize this distance, and for that we equate it with respect to A and B to get the values of A and B. Okay. Though our जो fitted equation है, it is used for the prediction purpose. Okay. As I told you, we will see one example also. That equation that we get y equals to A plus Bx, and it is used for the prediction purpose if we know the value of x and the other value of y. Okay, the thing that I want to tell you, sometimes there are two regression lines. Then there is this question, why two regression lines? What happens? As I told you, as I have told you in the initial start at the starting of the presentation, that there may be possibility that two variables x and y are interchangeable. It's with related to causal effect. One can consider x as independent variable and y as dependent variable. Y as independent variable and x as independent variable means x and y variables are such that in the cases in which we are confused which one to take as dependent variable and which one to take as the independent variable. In that case, I told you, so variable which you want to predict, take it as the dependent variable, and variable which you want to use for the prediction purpose, take it as the independent variable. Okay. So in that case, there are two regression lines. First one is the regression line of y on x, and the second one is the regression line of x on y. Y on x is y equals to A plus Bx plus E, है ना? And here y is your dependent variable, x is your independent variable, because we are using x to predict the value of y. Okay. The regression line of x on y, if we want to predict the value of x for the value of y, then we consider the regression line of x on y, b plus e. So both are valid regression equation, but we will have to judicially select which one regression equation is suitable, depending on which variable you want to predict. Depending on which variable to predict, you will consider your regression line accordingly, and you will consider your dependent and independent variable according to the problem, according to your problem. Okay. This is the one example that I have taken. Here is number of man hours and corresponding productivity in units are furnished below. We will fit a regression equation applying the method of least square. So this is man hours, productivity in units. This is the simple linear regression equation we have considered here. As I told you, to fit the linear regression equation, we will have to compute the value of A and B. So here the estimates of A and B are calculated using the least square estimates. So we get the normal equations as equation 1 and 2. Okay. And these values of summation xi, n is known, number of observation, summation xi, summation yi, summation xi square, xi yi, these all are computed from the data. This is suppose your x, this is your y, then we compute x into y, we compute x square, we compute all these things, and after that we sum this xi's, so we get summation xi's, we sum this yi's, we get summation yi's, we sum this xy, we get summation xiyi's, and in this way at last xi square also. So we put all these values in these equations, we get the value of a and b, and finally the values of a and b are put in your regression equation, and you can predict the value of y by using this equation. Okay. So it should be noted that the value of y can be estimated using the above fitted equation for the value of x in its range 3.6 to 10.7. This is that I told you when during correlation, that जो prediction है that can be done within the range only. Means for the values of x की range is from 3.6 to 10.7. So we can do the prediction for the values of x in the range 3.6 to 10.7. And this is quite true also, because we are fitting this model a plus bx to this data for these values only. Beyond these values, we cannot means if we can estimate also, that we cannot interpret that result. Interpretation cannot be done. So this is to be remembered that value should be estimated or calculated within this range of x, within the range of x only. Okay. So when we get this regression equation of y equals to 3.19 plus 1.48x, 48x, so it implies that, because this implies that for the unit change in the value of x, y changes by 1.48 value. Okay. If there is one unit change in the value of, if there is one unit change in x, then y changes by 1.48 units. Okay. So this is how you will interpret the regression equation. Simple linear regression equation assumptions are very important, because when you go for the SPSS, in SPSS, when you go for the interpretation purpose, means if you are using the large data to interpret the regression, to interpret the regression result, then the assumptions are very important. We will see the assumptions one by one, and after that we will see in SPSS how these assumptions are being met and how the result is being interpreted. Okay. So first thing is no outlier should be there. Two things you need to remember is independent variable that is used to predict the dependent variable. It always goes on the x-axis. X-axis पे ही रहेगा independent variable. Y-axis पे will be your dependent variable, and both must be scale variable. First one is no outliers, means if because regression is very sensitive to the outliers. So you will have to identify outliers in SPSS, and you will have to identify and you will have to deal with them. Means either you remove them, or you can delete, or do something else, or you can remove that observation also. You know, for that you need to check this residual. I will tell you in SPSS also. For that you need to check this residual uh, statistics box in your SPSS. It will show you the outliers, if there are outliers present or not. Means once you run regression, to standardize the bottom row in is standardized residual, and their minimum and maximum value should not exceed this minus 3.29 to 3.29. So if that value exceed this range, then you can say that that your data has outliers. If they don't, then you don't have outliers. You should have no extreme outliers. Okay. Another thing is you can also plot that box plot. You can draw the box plots for the data, and when you draw the box plot, it will show you the outliers. I will show you in Spss also that how it shows the outliers. It will show you the outliers, then remove those outliers. And another thing is this check your this residual statistics box. If the value is between minus 3.29 to 3.29, then it is okay. If it is beyond this range, then you need to be concerned about the outliers present in your data set. The residual variance should be normally distributed. The residual variance, called the residuals in the regression model, should be normally distributed. It means normality should be checked. और नॉर्मलिटी चेक करने के लिए मीन्स टू चेक नॉर्मलिटी वी क्रिएट अ पीपी प्लॉट. We create a PP plot in SPSS of residual errors, and then we use KS test, Kolmogorov-Smirnov test. Okay, KS test, and it will tell you about the normality. We will see in the SPSS also. Residual error should be independent. It means residual errors should be independent. They should not be auto-correlated. And it means independence of observation should also be checked. For that, use Durbin-Watson test, DW test, for independence of errors. And your Durbin-Watson statistics should range between 0 to 4. That statistic should range between 0 to 4. If it is close to 2, then it will be much better. Next is linearity. There should be linear relationship between two variables in the correlation. If not, then the model will not be significant. As I told you, linearity is must. To check for the linearity, create a scatter plot. It is not linear. If your data, if your points form a curve type of diagram or any cone type of diagram, so in that case, use non-linear regression. If such type of case arises, means if data is not linear. Collinearity in case of MLR, multiple linear regression. Collinearity, simple linear regression के case में you need not to check, but in multiple linear regression you need to check for the collinearity also. And collinearity means because in that multiple linear regression there are there are multiple predictors that we will use. So for that we will need to check for the collinearity. Or to check the collinearity, we need to look into the boxes for collinearity statistic. That is, we need to check for the tolerance and VIF. If your VIF is less than 10 and your tolerance is greater than 0.1, then we will say that your variables are not collinear. Then collinearity जो है that is okay. Homoscedasticity. Homoscedasticity means variance of residual error should be same across all values of your predictors on S. So to check for this, scatter plot the standardized residual errors against predicted errors in your SPSS, and they should be more elliptical. Means when you will plot the standardized residual errors and against the predicted errors, they should be elliptical like this. They should be scattered over at this X. Means they should be more elliptical. They should not be cone shaped or curved. So scatter plot showed heteroscedasticity. If your plot shows heteroscedasticity, it means if it shows any type of this variance shows your any type of this type of curve or something like that, then transform the data. And if these assumptions are violated, then you may not be able to use linear regression, but you still have options. Even if the assumptions are not being met, then you still have options. You will not be able to use simple linear regression in that case, but you can still use the another method, that is logistic regression. Where outcome variable is dichotomous. It means it is coded for 0 and 1. Or if predicted variable is categorical, then use t-test, one-way ANOVA, and there are many things that can be used. But you will not be able to use simple linear regression if these assumptions are not being met. So quickly, let us see this in SPSS, how this is being done. Okay. So we are going to see this for this data only. That is your groundwater survey data. And it is groundwater survey data. It is taken from Union Carbide Technical Report, and where Y shows pH of well water, X shows the bicarbonate parts per million of well water. And this data is by water well from random sample of wells in Northeast Texas. So what we will do is we will do the regression. In that case, we will predict the value of Y using the value of X. Okay. So we will start with a scatter plot. We will first of all we will check all that assumptions one by one. Okay. Then we will check the regression. Okay. Analyze. No, we want to draw the scatter plot. So we have already drawn scatter plot for this. No matter. Okay. So this is your scatter plot. This is scatter plot of pH level. So we can see, double click on it and draw the draw the line. So you can see that it follows the linear relationship. So our one assumption is being met of linear relationship. Okay. गो टू ग्राफ चार्ट बिल्डर स्कैटर प्लॉट और फिर उसके बाद जो जैसे हम स्कैटर प्लॉट ड्रॉ करते हैं. So what we have seen in the scatter plot is there was a negative correlation. We have seen in the graph that there is a negative correlation and dot goes to down. And we have also added this regression line which shows the negative correlation between the variables. Now we will check for the other assumption. So we can see that there is negative correlation. It means that your as the bicarbonate level increases, pH level goes down. Also, spread of data are similar all along the regression line. They are, you can see that they are not cone shaped or curved shaped. So we have established homoscedasticity and linearity. Now we need not to check for the collinearity, as this is there is only one predictor variable. So collinearity, as I told you, need to check when we are dealing with the multiple predictors. Now we are ready for the regression analysis. So going to analyze, go to regression. Okay. And after that, go to linear. When you will click linear, then this box will open. Now we are using pH of well water to predict bicarbonate of well water to predict the pH of water. Okay. So in that case, Y will go to your dependent variable, X will go to your independent variable. Okay. So in this way, in this box, bring your dependent variable and independent variable to their boxes. Move Y to dependent variable window, X to independent variable window, and that is bicarbonate level. Now we will go to the method. Method is enter. Okay. Now we will click on statistic. After clicking on a statistic, click confidence interval. We will also see the descriptive statistic. We want to see the Durbin-Watson test for the independence, as I've told you. We will see the case-wise diagnosis also, and click all these things. Collinearity diagnostic की ज़रूरत, we need not this because here is only one predictor variable we are having. So we will continue with this. Now we will go to the plots and move Z predicted to X and Z residual to Y. We want standardized residual plots, histogram and normal probability plot also, normality and that check करने के लिए. Now we will click continue. Now okay. So many boxes will open. Okay, from here see, so many boxes will open like this. We will interpret each and every box one by one. Okay, first one is the descriptive analysis. Descriptive statistic. तो सबसे पहले let's check the outliers and as I've told you, let's open that window also. No problem. Okay. To check for the outliers, I told you to see the residual statistics box. So let's see where is the residual statistics box. Here it is. This is your residual statistics box. Check this box, check the minimum and maximum. So you can see this standardized predicted value, minimum and maximum is between -2 to 1.9, -2 to 2. Okay. So it is within the range for the standardized residuals. Standardized residuals, it should not exceed -3.29 to 3.29. So it is within the range. So we can say that we do not have outliers. If the value exceeds this 3.29 and -3.29 to 3.29, then in that case we will go back to the data set, we will examine the scatter plot and we will deal with the outliers accordingly. Agar means it will be, if it will be data entry error, then you will have to check and you will have to return to the data set and you will have to check with the data again. And then if since our value is within the range, so we are not having any outlier in this case. Now we will check for independence of observation. So for that we need to see independence of error by using Durbin-Watson test. So let's see where is the Durbin-Watson test box. There, here it is, model summary. This is Durbin-Watson. So we don't want it to be less than 1 or greater than 3. So the assumptions of independence of observation has also been met here. It is less than 2. It is less than 3, approximately 2. So we have checked for independence of observation also. Now to check for the normality, go to the PP plot. This is your PP plot. Okay. This is your PP plot and you can see that dots are generally line up along this 45 degree line. This is 45 degree line. And if your points line up along this line, then we have normality of residual. And we can see that dependent variable X is normally distributed. We can say, to say that it is normally distributed, we will see the scatter plot of standardized predicted value versus the regression standardized residual. And if there is no pattern, as we can see, there is no pattern, values are scattered around. So if there is elliptical type of that is shown, then we say that this is they are not related. Okay. Now, since all the assumptions have been met, so since we need not to change anything, we have seen, let us start from the descriptive here, from the descriptive analysis. Yeah, from the descriptive statistics, which is showing mean statistics and means all the 34 values have been used. Then it is showing the correlation table, that is showing all the possible pairs, correlation between all the possible pairs, which we have discussed in correlation part. This is showing that we have used the method, enter method. Then this is showing model summary, Durbin-Watson test, independence के लिए we use this Anova table. Okay. Anova summary table is this is one another way of looking at our regression model, because regression, Anova, t-test, correlation all are part of GLM. So the significance value here means that our using means that our variable that we are using as a predictor and dependent variable. So if this value is significant, means if it comes out to less than 0.05, it shows that there is significant relationship between the predictor and dependent variable, means between the dependent variable and independent variable. This is dependent variable is pH level, and the predictor variable is bicarbonate level. So there is a significant relationship between the predictor and dependent variable. And if this ANOVA was not significant, so we cannot further move for the result or for the interpretation, because in that case our result will not be significant. It means जो predictors we have chosen, they are not contributing to output, है ना? So in that case means what you have to understand is, if this value is not less than 0.05, then we will say that that there is no significant, statistically there is no significant relationship between predictor and the dependent variable. Okay, now going to the next table. Hmm, coefficient. Okay, most important thing. Now we got to know that ANOVA table tells that model works. Okay. Now how it works means what will be the value of your coefficients A and B. Finally, we want the values of our coefficient, that is A and B, 8.098 and minus. So this your B, unstandardized B, shows your coefficients, that is 8.098 and minus 0.003. Okay, minus 0.003. So now you can write your regression equation as y equals to, this is your constant, that is A, that is A, it means 8.098 minus 0.003. So without going into the other details of this table, we will stick to this constants that we need for our regression equation. And by using these A and B, we will plug in these A and B in our regression equation, and we will create our regression equation as y equals to A, that is 8.098 minus 0.003x, and which shows, means if such type of result is coming, then it will show it means if we want to interpret it, then we will interpret in this way, that for every unit increase in our independent or predictor variable, the dependent variable will increase by obviously it is not increasing here, here it is minus sign, so we will say that predictor variable will decrease by this beta coefficient value, that is your minus 0.003 value for every unit increase in your x value, that is for every unit increase in your bicarbonate, that is ppm of well water, the pH level will decrease by minus 0.003. Okay, so this is your result. In this way, you will be able to uh, interpret your regression results. In the same way, you can do it for multiple linear regression also. So, multiple linear regression, as I have told you, when you are predicting independent variable from more than one dependent variable. All the procedure is same. Here you can see multiple linear regression equation is this: a plus b1 x1 plus b2 x2, like as many as independent variables are there. So first, the procedure is same as that of linear regression. First of all, we will check for all the assumptions, and after checking for all the assumptions, we will in this as compared to the previous one, we will also check for the collinearity. In this case, we will check linearity, collinearity, independence by using the Durbin-Watson test, normality of residuals, homoscedasticity. We will check all these things, and on the after that we will that report the result. So this is all about it.